Hey, hi, this is Mr. Secoder. Today, I'm going to discuss Educational Codeforces Round 87, Problem F, and this is an interesting problem named Summoning Minions. So, this is for all the minion lovers. Kidding. So, let's get into the question first, and then we discuss the solution to it. So, the question is stated in this way. A polycrab plays a computer game. In this game, the player summon armies of magical minions, which then fight each other. Polycrab can summon n different minions. The initial power level of ith minion is A of I, that was given by him, and when it is summoned, all previously summoned minion power levels are increased by B of I. So B of I and A of I is given for specific ith minion. The minion can be summoned in any order of your wish. So unfortunately, Polycrab cannot have more than k minions under his control. So to get rid of unwanted minions, after summoning them, he may destroy them. Each minion can be summoned and destroyed only once. That is logical. Polycrab goals is to summon the strongest possible army. Formerly, he wants to maximize the sum of power levels of all minions under his control. Those which are summoned are not destroyed, so those are under his control. So we need to help Polycrab to make up a plan of action to summon the strongest army possible of these minions. So the test cases are max of 75, and each test case he was given n and k. N is a number of minions and k is a possible controllable, like what are the maximum possible armies that are under your control. Not maximum, it's exactly. So you need to choose such a exactly k minions summoned in a given order. Okay, so he given two integers A of I and B of I. A of I is power level, and B of I is by which other power levels till now summoned will be increased. So what we need to print is, we need to print the order. Like if we choose different order, so we need to print that order. So firstly, print m, the number of actions which Polycrab has to perform, then print m integers, this O of I. So ith action is denoted as follows. If ith action is summoning the minion x, then O of I is a positive x. If ith action is to destroy the minion x, then it should be minus x. We need to print such things here. So if we take example here, the first one have 5 minions, and we need to have exactly 2 minions in our control. So what he did is, in the here he performed 4 operations. Firstly, he added, let me take this to a sketch pad and explain you. So this is a given minions. So let me expand this. Okay, this is a given minions power level, and this is number 1, 2, 3, 4. Sorry, this is 4 and 5. Okay, so what the answer that he given is this. So this is our answer for this test case. So he performed 4 operations. In the first operation, he summoned this 7th, that is second minion. So the actual power of this army is increased by 7. Okay, this is a B of I, and then he added this one, that is this one. So this was increased by 5 because he had the other minions here. This was second minion, right? Yeah, second minion here. So his level is increased by B of I, that is 3 plus 3. Okay, so this is a minion ID, and this is a power level he had, and this is the extra power that he gains by adding another minion. Okay, this is 5. Okay, so now he destroyed this minion. This is minion 1, right? He destroyed this minion. So from the sum we need to subtract this, and then he added fifth minion, that is this fifth minion, and so the power is total power is 7 plus 10 plus 3. So since B is 0, he can't increase other minions power level. So this is maximum power level of armies that he had, and he can control only two minions at any time of this operation. Okay, this is a problem. So we need to think of the strategy of how to approach this problem. So my advice is to first open that specific URL problem and then try it yourself, either it's brute force or whatever, try it yourself and then listen to the solution. In this way you can catch up the approach. So first of all, let's try to get some best strategy to play with these minions. So it's for sure that we need to add all minions, because in that way if we add some minion, the b of its b of 5 will be added to all the minions till now, so with which they will get somewhat maximum. So we need to add all the minions at least once and deleted destroyed later. So by this we can say that all minions should be summoned. So if someone is not summoned, so summoning and deleting, it won't make the answer worse, right? Because the answer will be incremented by b of 5. So, and at any operation the resulting number of minions should be exactly k. So if it lesser, we add the minions. Okay, if it lesser, we add the minions, and we need not delete now itself. We can delete later, because deleting is anywhere the same. Because let's say you add a minion here and you have a possibility of having 3 minions, then instead of deleting here you can also delete here. What it does is it will remove this 5. Okay, so instead of deleting anywhere, you can delete just after the adding of this minion. Okay, so just after the adding of the minion you can actually delete. So if the minion should be deleted, we delete just after the summon. That's what I'm saying now. So we combine all these things now. So we have to choose k minus 1 minions, because if you choose k from the kth minion, we will destroy all these things, all the minions, and the last minion that we are going to add is only summoning. Okay, so we think of the strategy like this: we choose k minus 1 minions and summoning them in some order, like depending on a b we need to summon, because if b goes b is higher, if it comes later it may increase some larger number of power levels. So we choose k minus 1 minions and summon them in some order, and then we choose m minus k minions, which will be summoned and instantly deleted. So that will increase only the b, that will add this b of 5 to all the minions, but not add this a of 5 value to the whole sum. So what we do then is we'll have one more minion, right? We'll summon that. Last minion is actually the summoning. So if you take a closer look at it, the first minion, if we add the first minion here, let's say it's some ith minion, let's say. So when you add the new, so it is at position, let's say this. So this is the actual value of that minion. So when you add the new minion, so let's say there are a1 so on to ai minions. Till now we have summoned, so this is less than k, let's say. And if you are adding some a of j I plus 1 minion, let's say. Okay, so what it does is all these power levels are increased by this b of I plus 1, right? So whatever the b of I plus 1, so this will get added to this. So what does it mean is, so what is our total effect or till now increasing the power levels? In increasing the power levels is you add this a of I plus 1 plus the, what are the possible minions till now is I, right? So this I into this b of I plus 1. Okay, this is a power levels that is added. So total power, this is the term that is added to the total power till now. So the first k minus minion 1 minions, we do the same. Okay, so if you consider this I plus 1 as I, then this will be reduce it to the form of I plus 1. So if there are if this is ith minion and if there are j minions till now, so the term that will be added to the total minimum power will be this a plus j minus 1 into b of I, where j is the number of minions that are till now present in the army till now. Okay, so first we'll add like this k minus 1 minions, and then from there we'll add 1 minion and destroy that minion. Why? Because after k minus 1, if we add 1 minion, the total number of minions till now will be k, exactly k. So after performing operations, we can't exceed this k value at any operation. So we can't add 2 more minions. We can only add 1 minion after k minus 1 minions present in the army. So if you add this minion and destroy, the net effect is, so if you add a minion, so what will be the case? Similarly, a of I plus, if there are j minions, you'll add j minus 1 into this b. Okay, sorry for my handwriting. So this will be added, and then since you are destroying, this a value will be destroyed. So the net effect that you increase is j minus 1 into b when you are adding and destroying. So we'll do such operations of n scale, and the last is actually only adding. So what does it increases? So you have the last let's say a of ith is it at the, we are adding this, summing this at last, so that is not destroyed. So till now we have k minus 1, because when you perform this operation, if this is the last operation that you are performing, so after performing this there should be k minions exactly. So till now you have k minus 1 minions, and for this you are adding this b of I. Okay, so this value will be added. So if you look at carefully this value, and before you're adding k minus 1 minions, right, this is looks similar. So what you can do is you can group this into 2 groups, either adding and staying till the end, or adding and destroying the minions of 2 categories. So one category is, so we can think in this way. So we have this k places where this minions power is incremented by a of I plus, if you have j minions, so sorry, if you have if so this is a of I minion is being added, and so the jth minion from this first group. So if there are j minus 1 minions till now, then the level of all these minions is increased by the specific b of ith minion. That is, if current minion is a jth minion that's being added to the group, after this there will be j minions in a first group. So let's say this is a k, and then there will be the rest, right? So each minion can either belong to the first group or second group. You need to choose, like if you here total you have n places. Okay, in this, so if you add the minion here, the power will be incremented like this. If j is a total number of minions, you have j minus 1. Okay, if you have if this is a jth minion that you are adding, so this is how the increment is. Or if you add here, if there are so if you add here, you know that there is already k minions here, so the thing that will be incremented by is b of I into this k minus 1. Okay, b of I into this k minus 1 will be added. So you need to choose whether either minion belonging to one of this group or this group. Even if it belongs to this group, it depends on the position. If we add here, since there are 1 minion here, and the power is incremented by the effect that this minion causes on the existing minions is b of I into 1. If you added this same minion here, this b of I will be added 2 times of it, because it will affect the first minion and if it affect the second minion also. Similarly, the b of I affects. So let's say we can solve this either using assignment problem algorithms like min cost flow algorithm or Hungarian algorithm, or we can also solve this using a DP approach. So we'll look after these approaches. In this video I'm going to discuss the DP approach. So let's see how we can solve with our DP approach here. So let's say we have this, right? Let's say if you're adding some minion to the let's say we divide this into, let's say these are k values, let's say. So because these are categories and these are n minus k, let's say these are total of, in the total you have n, right? So this is a first group and the rest belong to second group where the values only increment. So when you add that minion to this, if you choose the minion belong to this category, so the net effect that will be incremented by adding and destroying this category is this, okay? And if you add to this, then this will be a of I plus, so if there are if there are j, if there are already j minions, listen carefully, if there are j minions till now, let's say here we have 2 minions, right? J minions till now, it will be a of j into b of I. I'm not previously I have written the formula this, right? J minus 1 into b of I. This is actually if the current minion is jth minion, okay? If the current minion is jth minion, third minion, then this will be this case. Now I'm rephrasing this into quite differently. So if there are already j minions, okay, if there are already j minions, that will be incremented by b of I. Don't confuse with these notions, okay? So this will be the, so either minion will belong to this category or this category. So if this belongs to this category, we need to choose where this position is. So one way to avoid this calculation is, so you need to sort according to the b of I values, because the higher b of I value will have a probability of getting later, because if the b of I is higher than other b of I, then they should be occur here, because that will increase it by larger terms, okay? I think this point is clear. So what we have to do is we need to here we have 2 groups, right? First group is this category and second group is this category. We need to either put the minions into k minions into this category and remaining minions into this category. So each minion has each minion can be belong to either of the category, okay? So what we do is first we'll sort all the minions by b of I value, and so we define some state dp of some x comma this y, x comma this y, okay? So what x defines is, if this is a xth minion that we are going to add, and if there are already y minions in a first group, then that will be if there are already y minions, then we go to the state of, if we adding the xth minion to if we are adding this x minion to first group, then we go to the state of dp of x comma y plus 1. We go to the state of dp of y plus 1, because since we are adding this to this group, this will be incremented, this will be the state, and the value that will be added is the current value that you have in this specific state, plus since you are adding to the first group, this is a actual value that will be added. So this will be So this is a xth minion, right? So a of x plus, since you have y minions till now, y plus b of x. So this will be the value that will be added. So let's say if this is not adding to the specific group, first group, if this is adding to the second group, then this will go to the state of, sorry, before it's x plus 1 state, because the minions that you need to add is that. Okay, so just correct it. So now this will go to the state of y itself. It's not y plus 1, it's y. Previously here also that will be x plus 1 because the minions get incremented, so correct it. So here the y is not y plus 1 as of before, it's y, because the number of minions in the first group doesn't change because we are adding to the second group. So we go to the push dp and update this as follows. So let's look at the solution and you will get a clear idea of what we are doing. So I have read this n and k values here into the minions. So I have has defined the f as a first and s as second, so easy to look at. So mp as make pair, and sc is to get the size of this vector, and all is to simply write. So what this has defines would do is, if this sees any of the symbols that make pair, it used to replace at compile time this make pair. So similarly others. So in order to reduce the for loops, I used to use this. Okay, so let's go down. So here this we have defined here the max n is defined here. We know that max n can be 75, so I had one more than to that. So we define in this way what this is a pair of intent that a hash defined, so type def. So this is pair of intent. So this is a pair of intent of pair of ints. Okay, so in the first pair we'll store the actual a of I and b of I value, and here we'll store the index, because when you sorted, because for this purpose we are sorting, right? So in that case we should not lose the index value. Okay, so let's here I scan this and I iterated for the indices and read into this minions, added this id to here. Make sure that it's a 0 index, but what we are discussing with is 1 indexed, so we'll change that later. So we are defining the dp state, right? So what this is used for is so since you're using push dp, you need to know where you come from. For that purpose I use this position array. I will discuss it later, that will be clear. So I have initially sorted this minions according to the second value, if they are not same. If they are same according to the first value, that is I am sorting according to the b of I value. Okay, so I'm sorting according to the b of I value. Let's come here. Okay, so now I fill with the dp with minus infinity. So so what this state defines is the number of minions you have now till now and the first group minions. Okay, so for this state you will store the maximum possible power that you can gain for this specific army that you have built till now, and the position will the position will define which state you come from to this specific state. Okay, so we are using the top down approach, so bottom up approach, sorry. So this is the a value of the current minion and b value of the current minion that we are using, and this is 0 indexed now we are using. Okay, so if you have m minions till now, and m start for m minions. Okay, and we are processing the mth minion, m-1th minion, sorry. Okay, and this fg count is actually the first group count. Okay, and if this state is already calculated, first we will start from 0 0, right? So if we reach this specific state, from this state we can go to dp of m plus 1, since because we added one minion to now to the either the first group or second group, right? So the number of minions total in this both of the groups is m plus 1, and for the first group if you're adding to second group, then the actual this specific state value, so the total power till now will be the specific value, plus since you are adding here to this group, the value that will be incremented is k minus 1. So that what we are added here into b. So since we should know where we have to come from, because we actually need this order, right? Since we actually need this specific order, we need to know where we have come from. So for this purpose we used this position. So if you are adding to the first group, the first group count will be incremented, and you will go to the specific state in which you also add this a value plus whatever the first group count till now you have, so you will add that. So this is a DP approach. In this way we'll fill all the possible states, and now you need to segregate what belongs to the first group and what belongs to the second group, because each minion can have any other possibility. And DP, since we stored this first group count, so initially we need to have a first group of k. What we need to have exactly k minions, right? So first group is actually which retaining till the last point, and second group is which adding and destroying. Okay, so after performing all the operations, you need to have k minions. So the first group count should be k. So we'll backtrack now. M is actually stands for which minion. Okay, so you have m minions right now, and the first group count is this. If the first group count is same as the current state of first group count is same as the first group count, so what does it mean is you haven't incremented the first group count. So this specific minion is belong to the second group. If the first group count will be incremented, if this is not the same, this will be equal to this, right? So in that case you have added to the first group count instead. If not, you add it to the second group count. So now the first group count whatever will be as this, because we save it in the back we save it here to backtrack, right? So that what we use it here. So since we are coming from back, we need to reverse all this first group and second group of minions, because we need in a forward fashion. And you remembered or not, the last minion is always summoned. We grouped this, we added this into this specific group itself for simplicity of calculation. So this last minion that you have added here is the last one. So for this purpose, all these minions so size -1, so all these minions till instead of except the last one is already belong to the first operations that are summoned, and they are not destroyed. So you iterate over 0 to size of first group -1 and print all these things, and the second group belongs to the category of adding and deleting. So this belongs to the specific group. So that's why you added this minion ID and then you removed that. Okay, so and here since this belongs to last minion is actually the adding only. This is not deleted because you need exactly k minions, so that will be added. So this is our approach. I think this idea is clear, and the problem is super awesome. You try it out yourself, you submit the code, and it will accept the codes also. Submit and enjoy the problem, and you learn a lot from here. The DP state is achieved only when you sorted that. If you don't sort it, the answer will be wrong. This DP state is invalid if you don't sort it. Okay, keep that in mind. And if possible, I'll make a video on other two methods that I said, right? Min cost flow, with that also you can solve. So if possible, I'll make a video on it. So for now, thanks for watching. Stay tuned, and as you do, like, share and subscribe to my channel, and thank you. Thanks for watching. Bye bye.